Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Last time I stopped here, okay, and we were solving this question where we wanted to write the Nernst equation, okay, and for the cells in the preceding exercise, which was 917. So we had two parts. We saw two parts in 917, D and E. Now I did the I mean solve the question for part D. We are going to repeat again for part same thing, and we are going to solve the question for part E, right? Okay, so you just need to put that all together there, okay, so as to make sure that we have it here in one place, because I will need to get back to it this here, okay, okay, let me just move this here. Okay, so next I will need to get back to this question, of course. Okay, okay, so this is the quotient. Okay, okay. Now when we talk about this, just because I'm now going to continue, right? Okay, when we solve okay, so let me just do this here. Okay, I want to clear this page here. Okay, now I need to go and do the same thing for part E. Okay, now let's see. Part E, previously, okay, we did that for part E. Okay, so this is part E. See that? Okay, so I will just copy what we have for part E so as to work on that. Okay, so now let's see. The question here, this is part E. Fine. Okay, now what is it we want to do here? The question is asking me to write the Nernst equation. Okay, let me see if we have now. Okay, this is our question. What do I need? I will need to have the overall reaction. So definitely, right? Okay. So I will leave the two reduction half reactions, right? Okay. Reminding you that the question is asking me to write the Nernst equation. So I want to write the Nernst equation, right? Okay. So as a result, we have to know the overall reaction. We have written the overall reaction previously, so I copied it, and now it is here for us. Okay, now what do? I need actually to write the Nernst equation. So we Nernst equation, to remind you, last time we have used it, so we need also to use it now. Okay, so this is the Nernst equation, right? Okay, now we need, of course, to write the quotient. The quotient, of course, it should be written based on the overall reaction. Okay, so our quotient now will be written, okay, as sorry, that should be our quotient here. That should be quotient equal to what? Of course, I will need to write what? The activity quotient in terms of activities, right? Okay, so let's see. Activity of what? Here I'm looking at this here, this side, right? Okay, products over what? Reactants. So first the products, okay, and then the reactants. Okay, so this is the activity of the. Okay, so I will now start writing. Okay, so that should be activity of what? Activity of the products, but we have to make sure that it is what? Raised to the power that we have in the equation, multiplied by activity of Sn2 plus, this is aqueous, right? Okay, divided by activity of Fe2 plus aqueous. Okay, and of course this is also raised to the power of what? 2, and then I will take the 2 here. Okay, so and also here multiplied by the activity of Sn4 plus. All are aqueous solutions. Okay, now when we we talk about activity of solute, it is equal to activity. It is equal to the concentration of the solute divided by the standard concentration, and the standard concentration is going to be equal to 1 mole decimeter per decimeter cubed. Okay, so this is what we have for the solute. So it means that the quotient that I have here should be all replaced by what? They all have to be replaced by what? Concentration. Yani this one should be what? This should be what? Concentration, right? Okay, and this is also should be what? concentration, this is what concentration, and this is what also concentration. But noticing these concentrations will be raised to a power of what? They will be raised to a power of what? 2, right? Okay, so I will now write the concentration. So this is concentration, right? And this is also what? Concentration. This is also concentration, and this is also concentration. This, of course, should be, the power should be out. Okay, now, anyway, I don't have actually to say aqueous here because I am replacing the activities by concentration only for what? For aqueous, right? Okay, or sorry, for solutes, right? So it means that I already know that they are what? Solutes. Okay, so this is my what? This is my, okay, quotient. And the quotient, of course, as you are aware, should be what? We should be putting it where? In the Nernst equation. Now, our Nernst equation is already up there. What we need is what? We need, of course, to know that the nu here for this equation here, okay, or for this reaction, nu here, according to the written half reactions, nu is equal to 2. So nu is equal to 2. So if I write the Nernst equation, could be E cell equal to E cell standard, okay, minus RT over what? 2F, okay, and then we have what? Ln, and ln Q, of course, it is going to be this here. This is the ln Q, right? Okay, so this is our, okay, quotient for the reaction that we have, sorry, in part E, fine, okay? So that is the reaction that we are trying to solve the question for, which was asking us to write the Nernst equation. So I had to write the quotient. The quotient should be written based on the overall reaction. And since the overall reaction we have already found it from the previous question, okay, then we copied it and we used it. So this is now what we have, right? Okay, so this is it, right? Okay. Now, of course, we have other parts, but we are not. We have other parts, but we are not. I don't have time, of course, to solve everything. Now, see the Nernst equation for the cells in the preceding exercise, right? Okay. So this is what we have done now. Okay. So this, we don't need this anymore. Okay. 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 Now use the standard potentials of the electrodes to calculate the standard potentials of the cells in exercise 917. So that means I am still what? I am still talking about this exercise. يعني this could be like 917 could be a multi-part question. It could be, for example, part A, write the reaction, the electrode, write the half reactions, then write the cell reaction. Then we are asking you to write the, for example, the write the Nernst equation. Then we are asking you to find the standard potential. So it could be part A, part B, part C, part D, or a whole question. Okay, now use the standard potentials, okay, to find, okay, so it means as I said now, I will just go and what copy also. Okay, I'll copy part A, D, okay, and come back. Okay, so this is part D, right? Okay, and I will, okay, just copy whatever, and okay, look at what we need from that. Okay, so I will copy it so as to see what we need from that. Okay, now what I need is to calculate the potential, so I don't need this here. So I will calculate the potential, okay, standard potential, of course. So as to calculate the standard potential, of course, I will need to find the E standard here for this here, E standard here and E standard there, okay, because it is going to be for the left and for E standard for the left, E standard for the right, okay, and of course I will have to apply the equation, which is what? E right minus E left, okay, so our equation is going to be what? E right minus E left equal to E cell standard. This is the equation, right? We want to apply it. Okay, so as a result, I need to go to the table and I need to find E right and what? E left. So this is E right. So usually, as I said, as a common, make it a habit that whenever you go to the table to read the reduction half reactions, make it a habit that you also read the standard potential with it, because it will save some time. Okay. So we will go back and we will go to that. So we are going now to look at what? Look at the standard potential table, and we'll try to write the reduction half reactions. Okay, for our okay, these are the two reduction half reactions. Okay, so I will go there. So Br2 to Br minus, right? Okay, so Br2. So let's go there. Okay, I'll just need to clear everything that I have. Br2. So we are here. Br2, right? Okay, so it should be, it means here Br2, okay, this is 1.09, okay, and we have also Cl2, okay, and Cl minus, so 1.09, and we have Cl2, okay, and what? Cl2, this is Cl2, okay, so we have these are the values, right? Okay, so these are the values. So what we need is to write the values, okay, for the right and the left. So we have them. Okay, so let's go back. Okay, so 1.09 and 1.36. Okay, sorry. Okay, this is 1.09 volt. Of course, we have always to make sure that we write, sorry, we have always to make sure that we write the sign. Yani. It is important that we what? This should be plus, right? Okay, and that is going to be also plus, right? Okay, which is 1.36 volts, right? Okay, so it is important that we note the sign, right? Okay, because if we make a sign mistake here, it is going to be what? It is going to be a disaster, actually. Okay, so that means it is what? E sub is going to be E right, which is what? 1.09, okay, minus 1.36, which is going to be equal to minus 0.27, as you said, arrow volt. Okay, is that wrong? No, it's not wrong. Is it wrong? 1.09? Okay, it's not wrong. Why is it wrong? Why do you say it is wrong? It's not wrong. Okay, so that is going to be equal to the potential, right? Okay, for our electrode, which is, of course, for our cell reaction. Okay, of course, here I will have to say it is what? Non-spontaneous. And if I need to comment, I will say it is non-spontaneous. Okay, and it is in favor of, okay, reactants, in favor of reactants. So it is important that we note these things. Yani. When we have a sign, what does it mean? Positive, negative? Is it in favor of reactants? Is it in favor of products? Is it spontaneous? Is it not spontaneous? But it is important. Okay, now let's go and look at the other part, which is what? Part E. So part E is this here, right? Okay, so again, I will copy, okay, this part and we'll use it. Okay, part E. Okay, what do we have? Okay, as I said, I will copy. Okay, this is okay. Let me just go to another page better. Okay, so this is what we have here now. Okay, this is part E. Okay, now part E, of course, I don't need the Nernst equation now. Okay, I don't need the overall reaction now. Okay, right? I need only the left and the right. Okay, but I need to go to the table and read again. Okay, so I need to go to the table and read the E right and E left. So E right here, okay, equal to E left here equal to. Of course, we have Sn4 plus and Sn2 plus, and if E3 plus, if E3 minus, if E3 plus and if E2 plus. Sorry. So I will go there. Okay, now let's clear what we have here. Okay, okay. Now what we need is what? Is N. Okay, let's go first the Fe 2 plus, Fe 3 plus 2 plus, right? Okay, this is the reaction that I have here. This one here. Okay, Fe3 plus, Fe2 plus. Okay, and I have what? Also Sn4 plus, Sn2 plus. Of course, I will have to move it until there, right? Okay. So that is going to be, okay, what we have. Right, so we have what? We have 0.77 plus 0.77 and plus 0.15, okay? So this is what we have, okay? So this is sorry, 0.7 plus 0.77 volt and plus 0.15 volt, okay? Again, of course, you see E cell is equal to E is right minus E left. You write it and you substitute and you'll be able to get your answer. okay, which is what the potential cell, standard cell potential is going to be equal to, okay, we have 0.15 minus 0.77. Again, the answer is going to be what? Negative, right? Again, the answer is negative, which is what? Minus 0.62, right? Okay, negative. It means it is again the same, okay, same comment here. What is it? Same comment. It is what? That it is what? Non-spontaneous, and it is also in favor of what? In favor of reactants, right? Okay, so this is part A. Now let's go and look at another question. State what you would expect to happen to the cell potential when the following changes are made to the corresponding cells in exercise 917. Confirm your prediction by using the Nernst equation. Actually, I have to use the Nernst equation so as to be able to answer this question. Okay. Now, did we write the Nernst equation? Yes, actually we did. Okay, so we wrote the Nernst equation for both parts. Okay, so we will have to go back again, as this is what I said. Yani it looks, this could be one question with several parts, A, B, C, D, whatever. So that is what we are doing now. Okay, so let's go. I need the part which has Nernst equation. So I need this part which has what? Nernst equation. Okay, sorry. So what do I have to do? I will just copy everything, just to, sorry, I'll just copy everything and then we will look at what we need from that. Okay, this is what we have here. Okay, now where are we going? I'm going here. Okay, and I'm saying, okay, this is part D. Okay, part D, this is what I have in part D, right? Okay, so let me see if we have enough space here. Okay, so this is part D. Fine. Okay, so I have copied everything I need. Okay, okay, let me just do something here. Okay, we need actually to look at this question and say, well, what we need to know what is on the right, we need to know what is on the left, we need to know the overall reaction. طبعا if I am solving this question, like for example, I did not do this before, supposing I did not do all this before, and I want to answer the question, then I will have to write what? The right, the left, the overall, okay, and the quotient, and then I will have to do all this here and give the quotient, and this is the Nernst equation now, okay? Okay, now I will now need to look at the question. So this is my, okay, Nernst equation. I will go there and what? Do it here, okay? And I'm just copying everything that for you to know that we need to do all that so as to answer the question, in case we haven't done it before, okay, but we have, okay, so that's why I copied it. But in case I haven't done anything, then I will have to do all that. Okay, now the question, what does it say? It says what? It says what will happen, okay, if we, for example, if we, let me just do this here. What will happen if the concentration, see here, I want to answer this question, okay? So what will happen to the cell potential, okay, when the concentration of HCl is increased, okay? So this is what we want to look at, okay? I want to see what happens to the cell potential, okay? So that is my question, okay? Okay, what happens, okay? What happens, okay, to E cell? What happens, okay, to E cell, okay, if, right, concentration of HCl is increased, right? Okay, so what happens to E cell if the concentration of HCl is increased? Okay, then what is it I have to do? Now, let me just try to do something here. I say, okay, I am saying, for example, okay, I have, this is my cell, okay, I'm trying to find a picture for that I can use. Okay, so supposing this is my cell, okay, this is my cell, right? Okay, of course you could see that in your cell here you have platinum on the right and platinum on the left. Okay, when we okay, let me just go back all the way there, so you can see here, okay, when we, so we have here, you can see that, right? Okay, So we have platinum on the left and platinum on the right. Okay, and because why يعني طبعا لما we didn't have any solids in the reactions. In the reactions there are no solids. If you look at the reactions, you can see that there are no solids, right? Okay, so in the notation we have used platinum on the left and platinum on the right. Okay, that's why I'm trying to remind you. This is what that the same notation, right? I have. Okay, so as a result, I have here, this is supposed to be what? Platinum, okay, solid, and this is supposed to be what? Platinum solid. Okay, so now what else we have? Now I have in this in the cell here, I have two sides. I have the left hand side, I have the right hand side. The left hand side, I have what? I have you could see that I have Cl minus. It means it is what? It is actually HCl. Okay, see here, it is what? It is HCl. You can see that I have HCl. So I will write here, this is what? Of course, this is left, this is right. Okay, on the left, I have what? In the solution, I'm talking about the solution, HCl. And here at the other side here, okay, I have what? HBr. So HBr. Okay, now, why am I talking about that? Because I said now, the concentration of HCl is increased. How do I increase the concentration of HCl? I will add what? I will add here HCl, right? Okay, so I'm adding what? HCl here, right? Okay, I'm increasing the concentration of HCl. So I added HCl here. Okay, so what will happen now? If we add HCl, it means we are what? We are actually getting more of what? More of what? Of the, which one here? I'm talking about, I added more HCl. See here, okay, which is going to be affected here. Okay, which is going to be affected in the quotient here. I'm talking here. What is going to be affected? Okay, here in this quotient. Okay, I added Cl minus, right? Okay, so it means now I'm saying if, okay, if HCl, if concentration of HCl, okay, increases, okay, what happens? Okay, that means what? Concentration of what? Cl minus what? Increases. Okay, fine. Okay, now this is our quotient, right? Our quotient. Okay, it means what? This means what? This one what? What happens to this here? Okay, this quotient, right? Equal to quotient, right? Okay, this is quotient, right? This what? It what? Decreases, right? Okay, this what? Decreases, right? Okay. Now, then what happens also? Then also what? Actually, as you said, Arwa, actually the len, okay, the len of this also what? Len also, okay, also what? Then this here also what? It also what? Decreases, right? Okay, so it decreases, right? Okay, so it decreases. Fine. Okay, so if it decreases, let me just, okay, okay, so that decreases here, of course. Okay, it's not clear, it was not clear. So this is also what? This also what? Decreases. Fine? Okay, decreases. So what will happen if this decreases? What will happen to the quotient? Okay, let's look at the quotient now. Sorry, what happens to the E cell? Okay, the E cell. So no, you could see that this is what I have now. Okay, so I said now, okay, so let me just put it here, okay, just to make sure that that is clear. This here quotient, okay, it what? It decreases, right? Okay, and we have what? We have it now. We already know that it is now decreasing. So what will happen? What will be the effect if this decreases on the quotient? Sorry, on this whole side, this whole side. Okay, this whole side. So you said E cell will what? Increase, yes. If this decreases, okay, then, okay, it means what? Then E cell what? Increases. Fine. So this is our conclusion, right? Okay. But we have to explain, yani, when we, for example, if you have such a question, you cannot just simply just say, يعني it will increase or decrease, right? Okay. Then you have to explain, يعني, at least. Okay. Now, the other question here, okay, this is what we have. Okay. When what? Some, of course, I'm talking about part, I'm talking about what? part E now. Okay, so let's I will okay, put it here. So I will talk about part E now. Part E. Now I need actually to go and see what we've done in part E. Okay, let's go. Part E. This is part D. We are solving it. Now part E. This is what we did previously in part E, right? Okay, let's okay, try to put whatever here. Okay. Okay, so let's see to see what we need from that. Okay, I will put it here. Okay, and also I want so of course I don't need that now. Okay, I will remove it, but I need actually the part E. I need actually the Nernst equation. So this is the Nernst equation. Okay, we just did it today, right? Okay. So this is our Nernst equation, and we need to okay put it there. So okay, so let's put it and try to answer the question. Okay, so I have now this is the Nernst equation. Fine. Okay. Now, what we need is to do what? We need to actually يعني try to actually يعني try to represent يعني so that we imagine يعني what is, for example, the type of the cell or what is happening there. So I will say again, maybe I will use this here. I will say, okay, this is what I have. Okay. Now you could see that I have platinum on the left and platinum on the right. Okay, so I have platinum here, okay, on the left, and platinum on the right. So platinum solid, okay, it's platinum what solid here, okay, and of course I'll be able now to I'll be able to يعني put the other things. What are the other things that I have? طبعا I have on the left, I have Fe3 plus, Fe2 plus. So in the solution, I have what? Fe3 plus, okay? So Fe3 plus, okay, and Fe2 plus, okay? And here I have Sn 4 plus and Sn 2 plus, okay? So this is what we have. Okay, now we have now we are trying to do a change here in this cell so as to see if the cell potential will increase or decrease. Okay, what is the change I'm trying to do here? I said, okay, I will add if see here I am trying to add, okay, I'm trying to add some iron 3 chloride. So first of all, tell me what is the chemical formula of iron 3 iron, okay, 3 chloride, okay, iron 3 chloride. What is the chemical formula? Iron 3 chloride, okay, it is what? It is chemical formula, okay. So as to, يعني just to figure out, يعني because in our reaction here, we don't have this iron 3, okay, the chemical compound. Why are we telling the chemical compound? I'm asking about the chemical compound. What is it? Okay, what is it? The chemical compound. Chemical compound for, okay. Anyway, and I cannot waste more time here. Okay, it means now I will be adding يعني you have to يعني be quick in these things because it's time consuming. So I added Fe3 plus here, and also I added Fe3 plus there. Okay, so now what will be the effect on the yes, it is. Okay, if ECl3. So it is going to be what will be the effect on the cell potential. يعني طبعا we have to see the effect on the quotient, okay, so as to be able to see the effect on the E cell. So what will happen if I add Fe3 plus here, Fe3 plus there? What should happen now? Okay, I will get what? Okay, what is it going to be? Is it going to be, for example, so number increase, so which one? This one, numerator will increase, but I added both sides, يعني, okay? I added here and I add there, okay? So you are saying numerator will increase, okay? Why don't you also say also the numerator will increase? What is the reason, يعني? Okay? Numerator will increase, okay. Okay, but I added Fe3 plus both sides. Okay, why don't we يعني see if there is any effect of E3 plus on the right side. Okay, I'm asking يعني I'm asking a question يعني. Okay, I added if E3 plus on both sides. So what do I have to do now? Okay, how would it be affecting the quotient? Okay, these are the two reduction half reactions that we have. Okay, and based on the two reduction half reactions, we have the quotient. Okay, and our quotient, of course, is used in Nernst equation. Now I am saying, well, what should happen, or what would happen if I have added Fe3 plus both sides? What would it be? How would it be? Would it be okay? So it will be affecting only one side, right? Okay, it will be affecting only what? Where? It will be affecting where? Which side? Is it the right or the left? Okay, is it the right or the left? It will be affecting on the left, right? Okay, it won't be affecting the right because the right reaction is not involving what? It is not involving E3 plus, right? Okay, so it's not involving that, so it has nothing. So here, it's not going to be. It will be affecting only this here, right? Okay, so okay, so we say as okay, so as if E3 plus increases, okay, quotient what? Quotient Q increases, okay, right? Then Q, okay, then Q increases, right? Okay, fine. Then Q increases, okay. So what happens now if then Q increases? So then Q increases, okay. If then Q increases means what? It means what? All this side here, this side also what? Increases, right? Okay. So this side, okay. All this what? All this increases also. This also increases. Okay. So is it good now? Is it good? Okay. So it also increases. So what happened to the cell potential? E cell decreases, yes. Then, okay, E cell, okay, decreases. Okay. So this is what's happening. That E cell will be what? Okay, decreasing. Okay. Now these are two parts of this question. Okay. Now 927. Okay. Let's see. Have we solved 927 before? Okay. Are we? This is we solved nine. Okay. We solved 915. We solved 917. Now 18, 20, 25. Okay, and we are 27. Okay. Now let's see. This is number 27. Okay. Number 27 is a question asking me two parts question. Okay, the first part, calculate what? First part, calculate E cell standard. Okay. Second part, calculate E cell. Okay. So two parts. First part, calculate the standard potential. Second part, calculate the potential. Okay. The standard potential means we have to use what? E right, okay, minus what? E left. Then E cell, of course, it has to be, you have to use what? The Nernst equation, okay, to calculate, right? Okay, so that is what we have to do. So part A, we have to use we have to find E right, E left. Second, we have to use the Nernst equation. Okay, let's now talk about the first part. Okay, first part, what do we have? Part A. What is it we have? And you could see that I have a notation here, right? Okay, so this is what notation. This notation is supposed to be used so as to know what is happening on the left and what is happening on the right. Okay, so this is our what notation. Okay, now the notation that we have says, now let me just make sure that you read it properly. This is what we have. We have HG here, okay. We have HG, right? Okay. HG, it is what? Reduced or oxidized. And TL, okay. Okay. So HG, it is what? HG, it is oxidized, okay, on the left. And TL, it is what? Reduced, okay. So this is what? Oxidation here, okay. And this is what? Reduction, right? Okay. Now we have to write the two reduction half reactions. Okay. Now when we go to write the two reduction half reactions, of course we have to make sure that we are actually using the table properly. يعني in يعني as a something that is يعني important we notice يعني when we go to read the table sometimes we find the يعني we find the reaction يعني a whole reaction. Sometimes we only find the redox couple يعني. Sometimes we find, for example, a whole reaction. Sometimes it's just the redox couple. Okay. يعني we'll see that later on. I'm not going to يعني explain now here just theoretically. We will see it later on. Now let's look at the potential standard potential table. I need to have what this is this is what I have. Okay, it's GCl2. Now, what is the oxidation number here of G here in this here? What is the oxidation number? Should be what? G. This is Hg liquid and Hg here. What is it? Oxidation number. What is it? Okay. It is HgCl2. This chemistry, by the way, يعني. Okay. So that should be Hg2 plus. Okay. Okay. So we'll go to the table. The second one, it is what Tl. Okay. NO3. Okay. And what Tl. Okay. This is solid. Okay. And this is of course aqueous. Okay. And this one is aqueous. Okay. Now, all right. Okay. So what we have here. Okay. What we have here is this is what we need to have between the couple of these here, right? Okay, and the second one is supposed to be this is what we have, right? Okay, and okay, okay. So the second one it is supposed to be TL solid. What is it here we have in this? It should be what? It should be here actually TL it should be TL plus, right? Okay, it should be TL plus. So that should be TL plus here, okay? So it means what our couple is going to be what? Is going to be here TL plus, okay? And TL solid, right? Okay? So that is going to be this is the couple here. This is the aqueous, of course, right? Okay? And this is what? This is the solid, right? Okay? So that is what we need to go to find and from the table. So from the table, I will go and of course I will clear everything now. Okay, let's see here. We will have to have what? TL and TL plus. Okay, where is the TL? Of course, it is TL. It is not TI, by the way. It is TL. TL plus. See here. This is what we have. Okay. So let me just. So this is TL and TL plus, right? Okay. So this is the first one. Okay, second one. So it is what we have Hg, okay, Hg2 plus and Hg. So this is what we have. Okay, so we will write it in now. So what is on the right, okay, and what is on the left? Of course, always we start by the right. Okay, make it a habit. This is right. That is going to be what? That is going to be on the right. We have Tl plus 1 electron, giving me a TL, okay, solid. This is, of course, aqueous, right? Okay, this is, okay, on the left. And, of course, sorry, on the right. And E right is equal to plus, okay? I will make a space here. Okay, it is E right is equal to, okay, plus 0.34, plus 0.34, okay, from the table. Okay, plus 0.3, sorry, minus 0.34, minus 0.34. Okay, that is for the right. So we are looking where? We are looking at the right here. See reduction. Okay, where TL, okay, plus is reduced to TL solid. Okay, now the left side, it is the oxidation. Oxidation because it is what? Hg2 plus is what? Is what? Or Hg liquid is oxidized to Hg2 plus. Hg liquid is oxidized to Hg, okay, 2 plus. This is the, of course, on the left. So oxidation. Hg, okay, liquid is oxidized to Hg2 plus, but we are flipping as you are aware. Okay, so we are flipping as usual, right? Okay, but it is actually oxidation. Now, what is the E here? E on the left it is going to be equal to what? It is going to be plus 0.86 volt, right? Okay, so these are the two reaction half that we have to write for this cell reaction. Okay, now طبعا ان when we write the two reduction half reaction, as I said, we have to make sure that the number of electrons are matching. If they are not matching, then we have to multiply one of the we have to multiply by a factor. Okay, so that should be here. Okay, since they are not matching, this should be here 2, and this is 2, and this is also here what we have. What we have 2 here, right? Okay, so that should be 2 here. So now they are matching. So I have 2, 2, 2, they are matching. Because if they are not matching and I get the overall reaction, the number of electrons will not cancel, and we will get electrons in the overall reaction, and we cannot have electrons in the overall reaction. So that's why we will have to what? We have to do this here. Now we have to get the overall reaction. Okay, so right minus left. Why? Because I need to have the quotient. Okay, write the quotient, and the quotient is written for the overall reaction. So this is what we have, right? Okay, so I have here. Okay, this is what I have on the left of the first reaction, and this is the left of the second reaction. This is the right of the first reaction. Okay, and this is the right for the second reaction. Okay. Okay, so what is it I will do? I will now, of course, make sure that I am using the signs. Okay, this is minus this, okay, equal to minus, right? Okay, now you could see that now I'll be able to cancel the electrons. If I haven't multiplied by factor of 2, the electrons would not cancel, and these will what cancel. So as a result, I'll be able now, okay, to this is what cancel, this is also cancel. Okay, you'll be able now to move the negative terms to the opposite sides, right? Okay, so this will go to this side, and this will go. So we are going to rearrange our equation so as to have only positive signs on both sides. This is my equation. I will be what, of course, canceling now. Okay, canceling this here. Okay, and also what, canceling this here. Okay, and I'll be able to get what my equation here, that is going to be minus here. Okay, sorry. Okay, that is going to be minus, right? Okay, I don't need this. This is negative here. Of course, this is the other side. Okay, of course, as we are aware, we cannot have negative signs on the equation, so we are going to move to the opposite sign. So this, the final equation is going to be, okay, this here. Okay, I will move to this side and move to this side. Okay, this of course going to be what, positive, and this is going to be what, positive. Okay, so this is our what, our equation. So it's plus plus, and this is the overall equation, right? Okay, so the overall equation is going to be, okay, 2TL plus Hg liquids giving 2TL solid plus Hg2 plus aqueous, right? Okay, and now we are ready to write the quotient, right? Why? Because I need what, for part okay. Okay. I did not solve part A, right? Okay, so we have to solve part A. Part A, of course, should be is asking me to calculate what? To calculate the cell reaction, a standard cell reaction. Okay, standard cell reaction, which is E right minus what? E right minus E left, right? Okay, so this is the standard potential, okay, equation, and we have always to write it and substitute. So E cell standard is going to be equal to E right, which is minus 0.34, okay, minus 0.86, which is going to be equal to minus 1.20 volt. Of course, as you are aware, this is what, non-spontaneous, okay, non-spontaneous, and it is in favor of, okay, uh, in favor of products, reactants, sorry. Okay, now, part B now, part B. What do I have to do so as to do part B? Part B, I need to calculate E cell, okay? So as to calculate E cell, I need what? I need what? I need to, Okay, I will say find E cell. Okay, I need, of course, to have what? The overall reaction. Why do we need to have the overall reaction? Because I will need to write what? The quotient. Okay, it is important. So we come here. This is our what? This is our, okay, overall reaction, and we need the overall reaction. Okay, so we got the overall reaction, and now we will be able to use it so as to calculate. Fine. Okay, so let's write, of course, the let's write, sorry, let's write the Nernst equation so as to be able to substitute in it, right? Okay, so what is the Nernst equation? A Nernst equation, again, I'm repeating, it won't be given, you have to memorize it, and I have seen many students previously, they don't know the equations and they cannot they cannot solve because they don't remember the equations. Anyway, so this is the equation. Of course, you also need to know the constants here, right? Okay, what are the constants? And the constants, as we have said previously, they are what? R is always having this value, okay? This is the F, this is the T, okay? And we have what? We have to use these values. Okay, so the values that we have now, they are the values of what? The constants. Now, what if, for example, the value of the what if the value, for example, of the temperature is not given? Okay, the value is not given. What do we do if the value is not given? The value is not given, we use 25. Okay, what if another value of temperature is given? We have to use the given value. Okay, so now regarding the new here, okay, طبعا the new here is equal to what? According to what we have just written here, it is, you could see that the new is equal to what? You could see that we have what? 2 here and 2 there, right? Okay, so it is 2. So that is equal to 2. Okay, this is 2. Okay. All others are the values that we have the values here. You could see that we already have the other values that we need, which are these values, right? Okay, we are going to use them. Now we have the standard cell potential. We have just calculated it, right? Okay, E cell standard. Okay, it is equal to minus 1.20 volt, right? Okay. Now we need what? We need to write the quotient, and the quotient for this reaction is going to be equal to what? Of course, it is going to be equal to the activity of Hg2 plus aqueous, okay, times the activity of Tl solid, this is squared, activity of Hg liquid, okay, and activity of Tl plus squared, this is aqueous, right? Okay, so this is what we have now. Okay, you could see that my quotients are, or my quotient is in terms of activities. Okay, now, of course, you are aware that the activity of Hg2 plus will be replaced by concentration of Hg2 plus, okay? This is divided by the standard concentration, and the standard concentration is equal to 1 mole, okay, per decimeter cube, okay? Now, activity of Tl solid is equal to 1. Activity of Hg liquid is equal to 1. Activity of Tl plus, it is equal to the concentration of Tl plus divided by the standard concentration, and the standard concentration is equal to 1. So this is what we have, right? Okay, now, so it means that we are going now to go to our quotient and replace, okay, replace the, okay, so quotient is going to be equal to this, okay. I will be what? Replacing the activity of G2 plus by what? By this here, okay, but it is, this is what I have. This is supposed to be let me see, G, where is the G? Yeah, okay, yes, okay. And I will, of course, use also the activity of TL, which is equal to this, but this has to be what? It has to be squared, right? Okay, this has to be squared, right? Okay, so that means, okay, so this will be squared. Fine, okay, that is squared, right? Okay, so, okay. Okay, now I need actually I can just remove all that. Okay, and this is going to be just squared, right? Okay. Okay, now I have the quotient, right? Okay, now the quotient is equal to this. Is it correct? G2 plus, okay, over what? TL plus squared, right? Okay, so this is my quotient. Now what do I have to do? Of course, I will have to put it where in the nearest equation. So E cell here, okay, E cell, okay. Now also the question said what? D, find E cell. Find E cell when? For these information, given these information, find E cell given these information. So this is what? This is our, okay, question. Find E cell. Under what conditions? Okay, let me just make sure that I have a space here. Okay, I will try to move down. Okay, or I'll just have the question here. Okay, instead of moving down. So here, see here, says calculate what? Calculate the cell potential when the molar concentration of G2 plus. So we have that values now. Hg, okay, 2 plus is having a value equal to 0.23, okay, which is mole per decimeter cube, okay, and the concentration of TL, okay, plus it is equal to 0.72, okay, 0. It is also in mole per decimeter cube. Okay, so what do? We can calculate the quotient. So the quotient is going to be equal to what? It's going to be equal to 0.23 divided by 0.720, and this is all squared, right? Okay. After that, of course, we have to put it where? We have to put it in the nearest equation. So we have to go and what? Substitute the nearest equation. So E cell, okay, equal to E cell standard, which is minus 1.20, minus R, which is of course 8314, okay, RT, which is 298.15 over nu, which is equal to 2 F96485, okay, and then, okay, طبعا then Q, which we have just written here. So this is our Q, right? Okay, so we will put it there, and then you can, of course, calculate, right? Okay, you can calculate. So this is your equation that you can use to calculate the potential. طبعا once we calculate the potential, we will be able to say whether the potential is, for example, increasing or decreasing or like that. So you have calculated the value and you got what? You got minus 1.1896 volt. So you could see that the potential is doing what? Is it increasing or decreasing? The potential, is it increasing or decreasing? Is it decreasing? Math. This is math, يعني. Is it decreasing? It was minus 1.2, now it is minus 1. Yeah, if it is not decreasing, it should be increasing. يعني. It's the opposite, but it's not. The idea here is not we change. يعني. If I say is it whatever, you think that يعني, you notice that, well, I'm asking the same question and you think, well, it must be wrong, so I will change my answer. It's not like that. It is what يعني, these are يعني, very simple facts. يعني. This is minus 1.18. Yeah, it is very low. And I said that at the very beginning. I said we have to be careful, very careful here, because it is what? The values are of the cell potentials are very sensitive, and we are not supposed to be rounding off. If we round off, you might see at the end that the initial يعني, the value of the cell potential is equal to the value of the standard cell potential. Okay, this is what you are going to see if you round off. Okay, but actually they are not. Okay, there is a difference. Okay, minus 1.2 is not the same as minus 1.1896. Okay, there is a difference. Okay, so this is a question here. Okay, now this is also another question, which is what devising a cell in which the cell reaction is this here. So when we say device, the word device يعني means it will always mean that we have to write the cell notation. يعني we have to write the two reduction half reactions, of course. It says give the half reactions for the electrodes, okay? And then, okay, I will have to write the two reduction half reactions. Of course, the overall reaction is given. I have to write what? Okay, write the reduction half reactions. Okay, reduction half reactions. This is definitely, okay, and what? Write cell notation, okay. This is what we have to write the reduction half reactions, we have to write the cell notation, and there is another question here. Okay, it says from the standard potential of plus 2.54, deduce the standard potential of the Mn2 plus Mn couple. Now, how many couples here? And we have two couples. You could see that I have, for example, here, okay, the first couple, it is this here. Okay, one couple is this, and the other one is this. Okay, so one, it is for oxidation. Okay, this is oxidation, and the other one for reduction. Okay, so whether we have what? Mn, okay, solid. It is going to Mn 2 plus. Okay, and I have also Cl2. Okay, Cl2, which is of course gas. It is giving what is Cl minus. Okay, to Cl minus. Anyway, I'm just telling you that this is what's happening. So I have Mn2 plus and Mn couple. Okay, and I have what? I have Cl2 and Cl minus couple. Okay, so what we need now is to find the two reduction half reactions that involve these two. But the question said, okay, now what we, this is a question, when the question is asking me to do something, we have to do it as required. So the question says what? You have now the value of what? The is standard potential plus 2.54, okay? And you have to apply this equation. Now, E right minus what? Minus E left, okay. Now, which one is on the left, which one on the right? And if you see that this is what? Oxidation, it will be what? Left. And this is reduction, it will be right. Now, it means I will have to, this is going to be left, and this is going to be what? Right. Okay, now, I have that, I have to read the standard potential of the right and use it to find the standard potential of the left, because it is the unknown. Now, you might say, okay, I have it in the table. Yes, we know that you have it in the table, okay, but it is not allowed that you use the table now. You are supposed to be what? You are supposed to be calculating it yourself, because we gave you the value of the standard cell potential, right? Okay. So, previously, you used to do what? You used to find E right and E left, and then you have to use it to calculate E cell. Now you have to find, you are given E cell and you want to find the E for the left. Okay, so we are going to say, well, okay, actually I can represent this cell here. Okay, let me see if I can do this here. I will say, okay, will I be doing this here? If I want to represent the cell here, okay, will I be doing this or something else? Okay, let me just write the right, okay, the right and the left. Okay, so what we have is Cl2 gas plus 2 electrons giving 2 Cl minus, okay, and that is of course aqueous, okay. And of course, we go to the table and we read E standard, E right, okay, which is going to be equal to plus 0.136 volt, right from the table, of course, okay. Now the left, it is going to be Mn 2 plus 2 electrons, okay, giving, of course, this is aqueous here, okay, let me just, okay, this is aqueous, okay, aqueous, and it is giving me Mn solid, and that is the E left. E left, of course, is supposed to be, and I should not read it from the table because the question is asking me to find it. Okay, how to find it? Of course, I will use this equation. I will use this equation here, okay, which is E right minus E left. Okay, I already the question have given you the E of the cell. This is what has been given. So you use it to calculate the potential of the left electrode, and that is going to be like this here. So E right, we have it 1.36 minus E left. This is 2.54, and I'll find E left, and that is going to be equal to 1.36 minus 2.54. Of course, we'll be able to find the potential of the, okay, which is going to be equal to minus 1.18, like that, volt, okay? So now we want to talk about the notation. Okay, now the notation. Of course, you could see that I have M in solid, okay, at one side, okay, which is on the left. I have what? M in solid, M in solid. Okay, at the other side, of course, I must have a platinum because uh, I don't have a solid. Okay, here there is no solid here. Okay, there is no solid here. Okay, so I'll add platinum. Okay, so platinum. Okay, so that is going to be what I'm going to do here. Okay, so this is platinum. Okay, so on the left it is M in solid. In the solution it is M in 2 plus. Okay, or this Mn2 plus here. This is platinum. Of course, I have what? I have Cl2 and what? Cl minus. Now, actually, as you could see here, okay, in the question, I have only these two here. Okay, they belong only. Yeah, I have only one aqueous solution, MnCl2. It means I will have to add MnCl2 here, okay, and MnCl2 here. So would it be convenient or reasonable that I do that? I put two compartments with the same solution. Of course, it's not going to be convenient. So I will have to go and use the setup where I have, for example, this here, I have the Mn solid here, okay, and okay, Mn solid here, and M platinum solid here, okay, and it should be here in the solution. I have MnCl2, okay. This is going to be the correct, okay, setup, okay. So this is going to be the correct setup. This is not going to be the correct setup, right? Okay. So now, if I want to write the cell notation, how do I write it? I want to write the cell notation. So this is not going to be valid here, okay? This is not going to be valid, okay? What's going to be valid? It is this setup, right? Okay. So as a result, I don't need a salt bridge, okay? I don't need a salt bridge. So as a result, I will go and write the notation, okay, without a salt bridge. So what will it be? Of course, it will be Mn, okay, on the left, Mn solid, okay. I will have Mn, okay, Cl2, okay, aqueous, okay. Then I will have Cl2 gas, okay. Of course, I will have here what? Platinum solid. There is no salt bridge here, okay. So now let's talk about this question here. Device cells in which the following reaction are the reactions. In each case, state the value of nu, the value for nu to use in the Nernst equation. Okay. So when we say, as I said, when we say device cells, it means I will have to write the two reduction half reactions, and I will have to write the cell notation. Okay, so we are going to talk about the first one. Of course, I cannot solve all parts, so I'll choose some of the parts. Okay, so that is going to be, for example, the first part. Okay, sorry, the first part that I will be looking at. Okay, so this is the first part. So what do we have in this first part? I will go and look at the question here, okay, which is, okay, I want, of course, as I said now, we want to go and find we divide the cells So as to divide the cells, we have to write the two reduction half reactions, and we have to write the cell notation. Okay, and we want to find the value of nu. So this is what we want to do. Okay. Now, so I will start by writing the reduction half reactions. Of course, you could see that this is Fe, okay, and it is converted to that. So it means it is what? Let me just move it down here, okay. So this goes down here, and I have Fe converted to what? This one here. It means this is oxidation, okay, and of course this is going to be what? The reduction, all right, okay. So reduction, okay. So we have a right, okay, and we have what? Left, okay. Now let's go to see the table, okay. Let's go to this, see the table. On the right, I need to have what? I need to have a couple that is having PbSO4, for example, and PbS, right? Okay, if it is there in the table. If it is not there, for example, I might have to go and find what? something else يعني مثلا. Okay, which is for example between PB sorry, and PB, for example 2 plus, whatever. Okay, on the left I will have to find something that if E solid, and what? If E is O4, if possible. If not, of course I will find يعني a relation between, or a reduction half reaction between Fe2 plus and Fe. So Fe2 plus here, this is Fe2 plus, or okay, or Fe solid. Okay, so this is what I'm trying to do. Now let's go to the table. To the table. We will go to the table to see the of course first the reduction. Okay, the reduction. Okay, let's go and see the reduction. What will happen here? I am okay. Sorry, I am trying to okay, see the PB, okay, is for example, and PB. So is it there? See here, I have something here. Okay, see here, this is what I have. PB is O4, okay, PB is O4, and what? And PB. So I have it. So this is there. If it's not there, then I will have to look for example, something else, right? Okay, يعني, this is what I have this here. So I have to use it. So as a result, I'll be able to say, okay, this is my, okay, I will just, okay, okay, take it, okay, okay, right, okay. So now what is the other one? The other one, since I am here, I will say if E, okay, I have if E solid and if E is O4. Now if I go there, you could see that I don't have if E is O4 here. So I will take if E, okay, if E2 plus and if E, right, okay, because this is what is happening to the if E solid. It is converted to what? If E2 plus, sorry, okay, in our reaction. Okay, so we'll go back. Okay, now let's okay, we are going to okay, this is one, okay, and the other one, okay, is okay. So this is what I have. I have, this is on the left, on the right, okay, this is the right, okay, and okay, this is the right, okay, this is the right, fine, okay, and this is the left, okay, this is the left. Fine. So right and left. So I got them from where? From the table. Okay. So I have them from the table, right? Okay. So let's just try to make it clear here. Okay. So this is my the reduction half reaction, and this is the oxidation, but we are flipping as you are aware. Okay. So what is this here? This is E right. Okay, equal to this in volts, and this is E left, okay, equal to this value in volts. So we have the two reduction half reactions, the first one, which is on the right, and the second one, which is on the left, okay? So what do we do with these? Of course, you are aware that we have to what? We have to write the, first of all, the question is asking me to get what? The value of the value of the nu, and it is also asking me to write the cell notation. Write the cell notation. So nu here is equal to 2. You could see that it's equal to 2. Now how to write the cell notation? Okay, so we start with left, right? Okay, so we have the left. So that should be if E, okay, solid here. Of course, this is solid here. This one is solid. This is aqueous. So if E solid, I will say, sorry, I will say now I have what? Fe 2 plus aqueous. Okay, then I have what? I have salt bridge. Okay, so this is going to be salt bridge here. Okay, now what else I have? I will have to go to the other side. That should be what? PB is O4. Okay, aqueous. Okay, then I have a salt bridge. Sorry, I have a junction. Okay, because I have another phase here. That should be what? PB solid, right? Okay, so is it possible to write it differently? Yes, I can write it differently. It means this here, I can say, actually it is what? So I'm talking about what? The Fe, because originally in the equation I have what? I have Fe, sorry, I have Fe is O4. So I can simply write it, you can write it as what? Fe or Fe is O4 here, right? Okay, this is what you have. Okay, you can do it this way or that way. So I will say here or, okay, or, okay, this is what we have, right? Okay, so you write this way or that way. So this is what, this is the question, this is part A. Okay, so we have part A. Now, if we are going to talk about part B, okay, then what is it we will do? Of course, we are going, so let's just make sure that we are what? We know this is what answer here, right? Okay, answer. Okay. Now, let's talk about the second, for example, part B, this part, okay, of the same question, okay, of the same question. So what is it we will do? We will put it here so as to be able to answer. Okay, sorry. Okay, I'll go back. Okay, this is my part B. I want to solve it for, okay, okay. I want to solve part B for number 19. Okay, so it means I will have to, okay, I will have to do the same. It means I have to write the two reduction half reactions, and I have to write the cell notation, and I have to get the value of nu. So now when we write the two reduction half reactions, first of all, let's try to know what's happening here. Of course, you could see that this is going there. Okay, it means it is what? It is reduction. Okay, and this is what's happening here. It means it is oxidation. Okay, so oxidation. Okay, so now right, okay, and left, right and left. Okay, of course the right, the left, it is what? It is 2H plus 2 electrons, giving 2 H2 gas. Okay, and this E standard potential here is equal to 0. This is for the left. This is of course aqueous here. Okay, so this is aqueous. Okay, now on the right, what is it I have to do on the right? On the right, actually, I will see if I have a couple of that. What is the couple? Couple I have in my equation, it is Hg2Cl2, and I have what? Hg. I need to see if I have something in the table of this here. Let's see. So Hg2Cl2 and Hg. Let's go to the table. Okay. So what is there in the table? Okay, I want to look. Hg, let's see, Hg. Okay, do we have Hg? Okay, yeah, okay. It looks that I have something like that, which is what? Hg2Cl2. Okay, this one here. See here. Okay, this is what I have. Okay, so I want to, okay, use this here. Okay, okay. So we'll put it here. So now I have this, okay, this is what I have. Okay. Okay, so we'll use it now here. Okay, so we'll put it here. So this is on the right, okay? So that means I will be able, it means this is what? Now E right equal to this value. Okay, so this is what we have. Now if we look at the electrons, you can see that they are matching. See here, this is two electrons, two electrons. It means nu again here is equal to 2. So nu is equal to 2. Okay, so we have the right, we have the left. Okay, and nu is equal to 2. And what is the cell notation? Cell notation. Okay, of course we start with the left. Left, of course, we don't have, you can see I don't have a solid, so it is hydrogen electrode actually, so platinum solid. Okay, and I have, okay, H2 gas, right? Okay, and I have, okay, H2 gas, and I have H plus, okay, aqueous. Okay, so that is going to be one option يعني إن that I write it in terms of H plus. Okay, now I must have of course a salt bridge. Okay, so salt bridge here. Okay, so that is 1 and that is 2 salt bridge. Then at the other side, what is it I will have? At the other side I will have what? Hg2Cl2. This is of course this is solid, right? Okay, and then I have, okay, Hg, which is what? Liquid. Now, this is what a special type of electrode, which is we have I mentioned it previously, which is called caramel electrode, which is having this here a G liquid, يعني, and this is how we represent it. Okay, or we can, okay, represent the electrode. Okay, same here. Okay, I can say instead of what having it like this here, يعني instead of having H plus, instead of having H plus, I can have HCl. يعني instead of having here this one here H plus, I can have what? Okay, I can write it as what? As HCl, because this H plus comes from the HCl, right? Okay, so that is going to be, okay, I will say here, or okay, or okay, that, right? Okay, so this is one of the يعني يعني two options you have. You do a notation this way or that way. Okay, now let's try to do part okay, part C. Okay, part C, just to, this is part C. Okay, okay, see the question. Okay, it is part C. So okay, so what do we want to do now? Okay, we want to write the two reduction half reactions, and we want to write the, so we could see that here, okay, if you look here, H2 is what? It is oxidized, okay, and O2 is what? Is reduced. Okay, so H2 is oxidized, okay, and O2 is reduced, and we have seen that previously. Actually, we have seen this reaction previously. Okay, it is just يعني that now we are using it to يعني do something else يعني. So this is our reduction, this is our overall reaction, and we want to write the two reduction half reactions. Okay, so the first we have what? We have, we will start with the reduction, and this is oxidation. Okay, so what is it we have on the, for the oxidation? We have, of course, again, 2H plus 2 electrons giving us, sorry, we have, yes, we have 2H plus, okay, plus 2 electrons, giving us what? H2 gas, okay. Of course, this is aqueous here, right? Okay, this is aqueous here, okay. Sorry, okay. Here, that this gas, of course, here it is aqueous, right? And of course, the E here left is equal to 0, right? Okay, just the standard electrode, hydrogen electrode. Anyway, on the right, what is it I have? I have, of course, O2, okay, and I will have to have H plus, and I must have electrons to get what? H2O, right? Okay, So do we have this reduction, these two reduction half reactions, do we have them in the table? Yes, we have them in the table. Let's go and look at the table. Okay, I'm looking for, see here, okay, so here, I'm looking at O here. So see here, okay, so this is the reaction that I want to see here. This is the reduction half reaction, okay, sorry, this one. Okay, O2, H, okay, for electrons, whatever. So this is what we have to have. Of course, the other one, which is the see here, this one here, the hydrogen electrode, which we have seen many times previously, right? Okay, so let's go back here, and I will, okay, do this here. So here, see here, this is the, right? Okay, so O2 plus what? 4H plus, right? Okay, so O2 plus 4H plus, okay, plus also that is of course aqueous here, okay, aqueous, okay, plus of course 4 electrons, right? Okay, 4 electrons, okay, it is giving us 2H2O, right? Okay, so 4 electrons. Now if I look at my reaction, I will see that one reaction is having 2 electrons and the other one is having what, 4 electrons. Then it is not possible to leave the reaction as is. So I will have to multiply. Multiply, of course, the second reaction by 2. So this means this should be multiplied by 2 here. That should be 4. This should be 4, and this should be 2. Okay, so this should be 4, 4, and this should be 2, right? Okay, so we have 4, 4, and 2 H2 gas. And then at the top, and on the right, I have O2 plus 4 H plus 4 electrons, giving us, okay, 2H2O. So this is, of course, here, this 2H2O is air, this is liquid, right? This is liquid. Okay, so this is our this is what we need now for on the right, on the left. Now what is the cell notation? Cell notation, of course, on the left you have hydrogen electrode, so we need platinum solid. Okay, you will need H2, okay, that is gas, okay, and you will need the H plus, okay, so H plus aqueous, okay, and that is supposed to be, okay, H plus aqueous. You might add the H2O to it because it is there, يعني H2O liquid is there as a solvent, okay, and you need not now to have what, the salt bridge, right? Okay, and at the other side, of course, you have what, you will have the O2 gas, O2 gas, okay, and you have the of course the platinum, okay, electrode, because there is no electrode here, so platinum solid, right? Okay, so this is what we need to have. Okay, right. So this is our electrode, okay, which is going to be like actually I don't need a salt bridge here, okay, no salt bridge here, okay, because they have to be in the same side, because you could see that the two here, okay, are what, are, okay, the two reactants are what, combined with this one product, so we don't need a salt bridge here, there is no need for a salt bridge here. Okay, it means I will have to have the two electrodes, platinum electrodes, in the same container. In the end of the container, I will have what, I will have O2 gas at one side, H2 gas at the other side, and I will have H2O, okay, and the H plus, okay, in the solution. So this is it, okay. And of course, now it says what, 921, use the standard potentials of the electrodes to calculate the standard potentials of the cells device in exercise 919. Okay, so this is 919, right? Okay, and you could see that I have what? I have, every time I have looked at the, every time I have written standard potentials, I have written the value of the the standard potential. Okay, so I have written the standard potential of the right, of the left. Okay, why? Because as I said, it will be saving some appreciable time. if I had to calculate, for example, the potential as now we are going to do, we are going to calculate the standard potential of these cells, right? Okay. So how many cells we have? We have these cells, right? Okay. So I will just copy, okay, what we have here. So as to calculate the standard potentials, okay. So that is going to be the first part A, right? Okay, sorry, part B, this part B, right? Okay. We'll go to part A. Okay, we'll go to part A and we will copy, and we will then go to part B and do the same thing. So this is going to be here. Okay, I will come here and put it, and now I want to calculate the potential, right? Okay, so I will just do what? Yeah, use the equation, which is what? E right minus E left, okay, which is equal to the potential. So this is going to be the equation that we are going to apply in all. Okay, so that is easy. It should be E cell here. Okay, it is equal to minus 0.36. Okay, minus 0.44. That is going to be the first one. Okay, let's say part B now. Part B is this here. Okay, we will copy it so as to calculate. Okay, so this is part B, and we are going to put it there, and we can now also calculate. This is part B, right? Okay, so E cell is going to be E cell standard, okay, is going to be equal to plus 0.27 minus 0, which is plus 0.27 volt, right? Okay, that is going to be for the second one. Okay, now the okay, so the first is that, the second, and the third now. Okay, the third, it is going to be, okay, this one here. Okay, the third is going to be this one, okay, which we already have now, the standard potentials of the two reduction half reactions. Okay, okay, so that is easy, yani. Okay, we just need, okay, to, okay, so E cell, again, E cell is going to be standard E right 1.23 minus 0, which is equal to plus 1.23 volt, right? Okay, so that is going to be the question. Okay, now another question now says calculate the equilibrium constant of the following reactions at 25 from the standard potentials, standard potential data. Okay, so the first part is going to be this here, okay, which is, okay, going, it is this part, sorry. Okay, this is the, what we have, okay. Okay, so what is it we will do? Now we want to calculate what, sorry. Okay, we want to calculate the equilibrium constant. So what is the equation? Now they have to have the equation. So the equation for the equilibrium constant is going to be, it is what? Ln K equal to, okay, this is the equation. Ln K equal to nu F E cell, okay, over RT. Okay, just to remind you, okay, previously I have mentioned these values, right? Okay, so these are the values, okay, that we have, okay, we have used previously. So now we need what? We need actually to go and find what? Right, the two reaction half reactions. So what is it happening here? Okay, we will look at it. Okay, let's look at what we have here. So Sn solid is converted to Sn2 plus. So it is what? It is oxidation. Okay, and this is Sn4 plus is converted to Sn2 plus. So it is, means it is reduction. So I have what? I have right, okay, and I have left, and the right I have Sn4 plus 2 electrons giving Sn2 plus, Sn2 plus. Of course, this is aqueous, right? Okay, so this is aqueous, and this is also aqueous, right? Okay, so I need actually to have a space here so as to write the, okay. Now, of course, I need to go and read the E, but again, just remind you to be on the safe side. Always go and read the standard potential, read the reduction half reactions, and the standard potentials, of course, from the table. On the left, I have what? I have Sn, okay, 2 plus 2 electrons. It is giving me Sn, okay, solid, okay. Of course, this is of course also what aqueous, right? Okay, this is what also aqueous, right? Okay. So here we are looking at what? We are looking at the reaction, which is having values of, which is having يعني, these two reduction half reactions. What is it we have to do? Of course, we are going to read the cell potentials, okay, or reduction half reactions standard potentials from the table. Okay, from the table, of course, I will have to read Sn4 plus, and that should be equal to plus 0.15 volt, and E left is going to be equal to E left, which is minus 0.14 volt. Okay, Sn2 plus 2 electrons minus 0.1. Okay, and the other one, which is Sn4 plus 2 electrons, giving me it is plus 0.15, right? Okay, now I need to calculate the E cell. Of course, E cell, as you are aware, is equal to E cell E right minus E left. Okay, as we did it, as we used the equation previously. So that is going to be equal to E cell standard, which is E right, which is plus 0.15, okay, minus 0.14. It means it is equal to plus 0.29 volt. Okay, now, of course, now ln K is equal to what? Ln K, it is equal to, we are going to substitute. Now, according to the reduction half reactions here, nu is equal to what? Nu is equal to 2. See here, nu is equal to 2, right? Okay, so the value of nu is equal to 2. Let me just put it here. So that is what? 2 here, right? Okay, so the value of nu is equal to 2. Fine? Okay, so that is what we are going to use now. Okay, so this is the value of nu. So this is going to be what? Nu 2 F 96485. Okay, E, it is 0.29. Okay, volt. Okay, and we have what? R 8314. Okay, T 298.15. Of course, you have to calculate, and you have to give the answer, and that should be equal to then K. Of course, K is going to be equal to, okay, K is going to be equal to E, and the value that we get from here, okay, we put it here and find the answer. Okay, so put the value here and find the answer. Okay, so you get you have to right. Okay, you need to calculate the answer here. Okay, you put it here. Okay, and you must calculate, of course, and get the answer, final answer, right? Okay, so that should be, okay, that should be here. Okay, you need to give the answers. Okay, so this is it. Okay, now of course another question here in the same, another part, like here, this part here. Okay, another part, this part B, for example. Okay, of course you could see the answers here. The answer here is given. For example, part A, right? It is supposed to be equal to this value, more or less, yani. Okay. Uh, let's see here what we have. Okay. Now this is another part. I want to calculate also the value of K. So how do we calculate the value of K? Of course, we have to get the two reduction half reactions, so as to know the number of the value of nu, and we have also to calculate the E cell. Okay, and then of course we should be able to find the value of ln Q. Okay, ln K, and then K, of course. Okay, so what do we have to do? Of course, we will have to go and يعني طبعا before we do anything, we have to make sure that we know what is happening in this reaction. You could see that this is what? Cn, okay, this is Cn, okay, which is, for example, solid. It is converted to that, which means it is oxidized, okay. And of course, you could see here, this is what we have here. So it means it is what? There is what? This is the reduction. Okay, let me just move it down. So this is, okay, the reduction. Okay. And now, as I said previously, when we go to the table, we have to make sure that what we have in the table, okay, is it do we have our reaction in the table? I need, for example, on the left and we start always with the right, so the right, the left, okay. So this is on the right, okay. I need to have, for example, ag, br, and what ag, right, okay. That is in the, if I have a reduction half reaction that involves these two in my table, I will use it. Otherwise I will use, for example, ag and ag plus, for example, if I don't have anything, yani. But let's see if we have it. And then we have on the left, I have what? I have Sn and what? And Sn Br2. Okay, so do we have these in the table? Let's go to the table. We look at the first one, AgBr and Ag. AgBr and Ag. Let's see. Okay, so let me just okay, go and do okay, put them there so as to okay. So this is what I have. Okay, I'm going to okay do this here. So let's see here. Do I have AgBr and Ag? AgBr and Ag. Let's see here. We have here AgBr and Ag. Yes, we have it. Okay. So this is what one. This is one. This is what one of that. Okay, so I will use this here. I will need it. Okay, that is what? That is okay. Now the other one, what is the other one that I'm looking for? The other one that I'm looking for is this here. Okay, which is what? Sn. All right. Okay, Sn and SnBr2. Do I have? Let's go. Sn. Do I have it? No, actually, nothing is there. I have Sn, okay, and in Sn 2 plus. See here, this is what I have. Sn, okay, giving Sn, okay, Sn2 plus Sn and S4 plus is, so my reaction actually, it is Sn, this one here. My reaction is involving this here, okay. That is going to be the, okay, okay. So we will go back, okay. Let's now copy what we need, okay. This one here, and also I need this one here, okay. Sorry, okay, I need, okay, sorry, okay. So these are the two reduction half reactions, okay. Now one is going to be on the right, which is going to be this one on the right, okay, and this one is going to be on the left, okay. So these are the two reduction half reactions, and I have got them from the table, right, okay. And as I said, every time you go to the table, you have to read the okay, the potential also. So that is ER here, okay, equal to this value, and this is E left, which is equal to this value. Okay, now this is what we need, and we will be able to, of course, we'll be able to calculate, okay, calculate the, the question is asking me to calculate the equilibrium constant, okay, so I need to calculate the equilibrium constant. Now, what else? طبعا we need to go and what? We need to go and give the value of the nu, okay? And we have these are the constants that we need, okay? And we need the, of course, the equation for ln k. So as to calculate k, the value of ln k will be calculated first, then we calculate the value of k. What we need is to know the value of nu. You could see that the reaction, the first reaction is having one electron, and the second reaction is having what, two electrons. So I must multiply the first reaction by a factor. So I will write it again here. So that should be here 2AgBr. This is of course a solid, okay, plus two electrons is giving me, okay, 2Ag. That is of course a solid. okay, plus 2Br minus, which is aqueous, okay. And of course, this reaction is having reduction half reaction equal to, okay, from the table we got it, we got the here we got it E, right, it is equal to plus 0.1073 volt, right, okay. This is what we got from the table, okay. So when we look at the, thank you, thank you, I'll stop here and continue next time.